You did make it. Welcome. Awesome. Thank you. Brendan just arrived, as everyone could see, so we're excited to have Brendan here. He just came in from California last night, where he did a big announcement at the Red Hat Summit. So in this session, we're going to talk about Azure Resource Manager and really how you can make your production deployments immutable, declarable, repeatable, and we're going to talk really across three areas. Before we get into the agenda, I'll give my intro and then I'll let Brendan talk about his. I've been at Microsoft for just under 20 years, really right fresh out of college. Spent a lot of time on focusing a lot of infrastructure scenarios, a lot of management scenarios, worked on low-level things in Windows like WMI, lots of System Center monitoring pieces, application performance monitoring. But the funnest part of my career has really been these last few years. This cloud transition, been through lots of other transitions across physical to virtual, so from sort of on-prem into the cloud. Spent a lot of time really focusing on IT scenarios, core IT, working with lots and lots of teams. And now I'm working on the ARM product and future with Brendan.
Cool. Thanks so much. Thanks to the sound guy who mic'd me up at the last minute. So I'm Brendan Burns. I'm the engineering manager for the Azure Resource Manager team. Unlike Vlad, I'm actually comparatively new to Microsoft. I came over a little under 2 years ago. And I think really because of the cloud transformation. I've been doing public cloud for a while, and I've been really interested in enabling people to build and manage reliably build and manage distributed systems up on the public cloud. Along the way, and in addition to working on ARM, I've done a lot of work with containers, and I started the Kubernetes open source project, one of 3 people here in Seattle who started the Kubernetes open source project for orchestrating containers. Had some big announcements around containers and Azure over the last couple of days, so if you haven't checked those out, definitely go and check those out. They're pretty exciting. But today we're going to talk about Azure Resource Manager and why it's interesting to you. I've done a lot of various things in the cloud, so I'm happy to talk about that stuff as well, either Twitter or afterwards. I'll be hanging out all day. So, cool.
Great. So from an agenda perspective, Brendan's going to take us through sort of what we've learned so far, a couple things that he's learned building software through all of these transitions, especially around containers. And then we're really going to talk about the 2 sides of Azure Resource Manager, the sort of consumption side. How do you consume different Azure services, the different patterns for them, what ARM provides, some of the different patterns we've seen from our customers. And then we're going to also talk about the production side, how you can make the things that you build in Azure available to other people within your enterprise or with everybody else to then consume. So sort of a production consumption sort of loop that we use. So I'll give you the clicker for this.
All right, cool. So I want to talk a little bit about the motivations for ARM and the motivations for using templates. And some experiences that I've had and some insight that I think guides the ARM team in general. So the first and the primary insight that I think I bring to the table, and I think this resonates with a lot of people, is that most outages that you have out in your software, out in applications that you've deployed out into the cloud are self-inflicted. And this has certainly been the case for ARM even, right? The ARM team, I probably shouldn't tell you, but the ARM team occasionally has outages. We have people on call who react quite quickly and fix things, or sometimes even automated mitigation that fixes things. But in many cases, these outages are caused by changes that we made that had unanticipated consequences, right? And it's not that somebody wakes up on the team and says, you know what? Didn't test this thing, not really sure that it works, let's push it everywhere. That's not what happens. But what happens is that you don't necessarily understand the way that your environment looks, or you don't necessarily understand the consequences of a change that you're making into the environment, and those not really fully understanding what's going on leads to an outage later on down the stream. And so if there's anything that we're really trying to do with Azure Resource Manager, and honestly, actually, a lot of the way that we are evolving how we approach developing cloud-based applications, it's to fix this, right? It's to make sure that you're well aware of every single change that you're making, well aware of your ecosystem as well, and the way that your application is working. So with that as sort of the inspiration for the technology and the techniques that you're going to be seeing, I want to talk also about, like, well, how does ARM then approach solving this problem? How does ARM make it easier for you to build reliable infrastructure? And the real goal behind it, effectively, is to move to what's been called immutable infrastructure, or infrastructure as code, or there's a variety of different industry buzzwords that come and go, but they basically come down to some simple principles. One of the main goals is to have repeatable configuration. So if you think about what's the difference between an artisanal, handcrafted, bespoke distributed system and something that is, maybe it could be mass manufactured, it's that repeatability, it's that consistency, it's the ability to know for sure that every single time when you go to deploy something, you're going to get exactly the same thing that you wanted, right? There are no manual steps where you tie something on, or I think of these sort of, systems where there's lots of copper piping and it's leather and it's very beautiful, but if you touch it, it falls apart, right? We don't want to build systems like that. We want to build systems that are much more like a car rolling off an assembly line. Every 2 minutes, the exact same car comes off that line. That's a really important piece of why you move from more imperative configuration, from scripts and manual configuration steps, to something like ARM templates. But in addition to that, the goal of having that repeatable configuration, another really important thing is to actually understand what's going on. And so one of the other reasons why you move to an ARM template is to provide yourself with better introspection. Right? So as you see what we're talking about here, and as Vlad goes through a lot of the features that are inside of ARM, another theme that I want you to be thinking about is, how does this give me the ability to figure out what's going on, right? If there's 4 different scripts spread across a bunch of different repositories or different people's machines, even worse, it's very hard to actually understand how something came into existence. Or if you hand a machine from someone who provisions the machine to someone who configures the machine to someone who installs the application on the machine, there's not one source of truth that describes what the application that you're deploying looks like. So the ability not only to repeatably deploy something, because you could repeatably deploy something through a very manual process, but also to be able to introspect that artifact and understand what it's doing, where it's going, what are the changes that it's making to the world when you create that application. That's a really important piece of, again, getting to a place where we fully understand our system, and in our outages, we don't inflict outages upon ourselves. All right. Another really important piece of the puzzle is actually having more than one person, right? So it's great if I can repeatably deploy something, and it's great if I can look at the world and understand what my application looks like, but I actually really want to have someone else do a double check for me. Or to have some source of record that shows me what changed, right? We think about this in our source control systems all the time, right? I think at this point, the idea of source control and the idea of code review are non-controversial. Now, the truth is that when I started in this industry, both of those things were actually a little bit controversial, at least. Like, you could go into a room like this, and definitely code review didn't exist, as far as I remember. And there were actually people who didn't necessarily use source control, right? Who had a big shared drive where the source, or maybe that was the source control, was a shared drive. But the notion that you should have the changes that you're making to software be auditable and be inspected by other people before they're committed is something that has, at this point, become sort of an accepted practice and a standard practice in the software industry. I think that we're farther along or farther back on the curve when it comes to our infrastructure. Right? And so one of the other goals, in addition to being able to repeatedly stamp out your application so that it comes out exactly the same every time, and to be able to understand exactly what that application is made of, by moving to a template-based approach, by moving to a single document that describes your entire infrastructure, suddenly you can code review changes. Right? You can say, hey, you know what? I want someone else to double check that this change that I'm making to my infrastructure is a sane change. And if the change happens to break things, well, you actually have an audit trail as well that can show you, well, what was the last change? I had something that was working. I deployed something new that's not. What was the piece that changed? That's hugely powerful in terms of your ability to prevent outages via introspection and react to outages via understanding the differences in the world. All right, so the answer to all of those goals is this idea of declarative configuration. And declarative configuration stands in opposition to what we call imperative configuration or imperative management. And to sort of give you an analogy for why this is valuable and why this is important, this is the sort of two pictures that I would give you. On the left. On the left, we have a thermostat, right? And with a thermostat, you declare a state, right? You say something like, I would like this room to be 70 degrees. And an automated system, or in this case actually a mechanical system, takes that input and makes changes to the environment to make the current state of the environment match up to the declared state of the environment, right? The thermostat is a declarative configuration of the world. Your other option, if you want your world to be 70 degrees, is to have a thermometer in one hand and a match in the other, hopefully something bigger than a match perhaps, and to basically heat or cool the room manually by turning on that heat or turning off that heat until the thermometer reads the correct temperature. You can imagine that in one case, simply setting the knob and going away is far more repeatable, far more reliable, far more introspectable. It's auditable. Somebody can come along and say, why is it so hot in here? The thermostat is set to 75 degrees. In the case of imperative configuration, once the room is at a certain temperature, you don't necessarily know or remember how you got there or why you got there or who is the person who is lighting things on fire. It's a bad world if there isn't a record, there isn't a declared state, right? And so hopefully this analogy, and I think no one in this world would be thinking about heating their room with a torch. But a lot of times when you're running a script or you're logging into a machine and manually running commands with Bash or with PowerShell, you're effectively, lighting something on fire in your room to get it to be the right temperature. And that should strike you as a bad idea. So really with ARM, in order to achieve ultimately the goal of a reliable system, we're moving to this world of a declarative configuration where you, instead of setting a thermostat, obviously an application that you deploy to the cloud is more complicated than that, you're actually declaring your desired state to be something like, I want 3 virtual machines with this software installed on them. I want a load balancer in front of them. I want a storage account to be used for backups. I want to turn on a shared service like Cosmos DB. I'm going to declare everything, and I'm not going to actually do anything. I'm simply going to tell Azure, this is my declaration of what the state should be. And just like the thermostat takes care of heating and cooling the room until it achieves the right temperature, Azure Resource Manager is going to take that declaration of the world and take all of the actions necessary, deal with failures if they happen, take all of the actions that it possibly can to drive the current state of the world to match your desired state of the world. That's hugely powerful. It means that once I throw up a template for my application, I close my laptop, I walk away, the application comes up repeatably, reliably every single time. It's incredibly powerful because once I check that template into source control, I can have an audit trail where somebody can come along and say, why are there 4 virtual machines here? There were supposed to be 5. And they can see the change that somebody else made in that template to reduce the number of virtual machines. They may even see a description of why the change happened, right? Someone has code, and they can also say, well, not only can I see why it happened and who made the change, but I see a review over here where there was a discussion between 2 of my developers talking about how we were over-provisioned and it would be cheaper if we went down to 4 VMs, right? So the switch to declarative configuration and the switch to using things like ARM templates and a lot of the techniques and technology that Vlad is going to talk about really helps us along the way towards our end goal, again, which is reliable, repeatable applications. All right, so this is basically what it looks like if you haven't seen an ARM template. There's going to be a lot of other descriptions of it, but it's a JSON file. It's got a bunch of parameters that can make it configurable. One thing that I didn't mention that is a nice byproduct of this declarative infrastructure is that you can actually make it parameterizable. So you can actually create templates that are like functions that take parameters in and maybe produce a small-sized application for your developer and a large-sized application for your production using exactly the same template. And we're going to see a ton more examples of this through all of the great demos that Vlad is going to show us for the rest of the time here. So hopefully that's given you some motivation for why we are interested in doing this. And we'll be around afterwards to answer questions as well. So thanks. Here you go, Vlad.
Great. Awesome. Thanks, Brendan. So how many people are brand new to Azure? Pretty new to ARM templates? There's a few of you. So I've got 2 slides just to bear with for people who already understand ARM. We'll sort of come back to this lots. If you think about ARM, ARM is this control plane for all of Azure. It's an API endpoint that exposes all of Azure services. It doesn't define the Azure services. Those are defined by the teams that expose things in Azure through resource providers or other templates or managed apps, and we'll talk about lots of those. But it provides a lot of commonality across the life cycle of these services. It provides an API where you can imperatively change the scale of resource, stop a VM, do different actions over this REST API, or you could give it this template where you can monitor deployment and you can see it do things in action. There's many clients, so if you've used the Azure portal, you've deployed a template. If you've used our command line or PowerShell or other tools, you've deployed templates. Lots of people at Build that we've been talking to this week use a whole pipeline in Visual Studio and release management and deploy templates that way, and spend a lot of time thinking about what's the composability of their templates. In Brendan's sort of thermostat example, how do sort of many thermostats work sort of in a room in conjunction? Maybe you have sort of a thermostat in a number of different rooms on your first floor and a number of different rooms on your second floor, and maybe that's your test room, and then you have sort of an apartment building where you're sort of trying to make sure the temperature is sort of in sync across all of them, or you're having then thermostats working in a hospital where you have sort of rooms that have to be kept in very sort of tight control. But you're going to use the same thermostat. You're going to use the same sort of template, the same declarative configuration, but it's going to have different parameters and different maybe tolerances and thresholds and sort of time to respond, because some thermostats are working with sort of maybe it's controlling many different sources of heat or many sources of cooling, and depending on the variation of how fast it needs to get, it's there. Or maybe they're taking in a parameter on the cost of your budget that you're allowed to spend. And if you have a big temperature gap that you're trying to get, or a big sort of request load that you're trying to close, how could you maybe scale a little bit higher to sort of get through that request load if you have the budget to do it. Now, this control plane that we'll talk about a lot is defined through these resource providers. Resource providers define what's in this control plane, and therefore what is addressable by Azure Resource Manager. We talk a lot about this control plane and data plane, and in many ways it's arbitrary as to sort of where a team defines sort of where their control plane ends and where their data plane begins. And certain cases we've had things that were never part of the control plane until the resource provider chooses to make it part of the control plane, and then therefore it's part of the control plane. For example, a storage account, creating a storage account has always been in the control plane. But creating containers, queues, tables, other actions, other activities within a storage account were never part of the control plane until just recently the storage team is working on exposing containers as the control plane. But creating a blob inside a container is not part of the control plane. Things that are part of control plane are really activities that don't require a lot of data to be processed. This ARM front door endpoint has an 8 megabyte limit for a particular request size. So if it is larger than 8 megabytes, if you're going to do a big Cosmos DB query and trying to get all your records, all of your orders, that should never go through the ARM control plane. That is not sort of something that we would through a review process sort of want a resource provider team, a service team to model within the control plane, because your template shouldn't create it. That should really be a data plane operation. A couple other examples, virtual machines, the RDPing to a virtual machine does not go through the control plane, does not go through ARM. That goes directly to the compute service, directly to the VM, over the VNets, over the different network infrastructure that you deployed for a VM. If that VM is on a public internet-facing endpoint, you could get to it directly. If it's on a private internet endpoint, maybe you have to tunnel and get to the VNet, and then from there you can term serve into the machine or SSH into the machine. Those go over data. Those are data plane operations. There's a few interesting cases, especially around virtual machines, where you can do things sort of in-guest into the VM through this extension mechanism that's exposed on the virtual machine resource, where you can upload a custom script, do a particular action, install an extension that gives you this ability to run logic within a virtual machine and then have it do some action and then sort of marshal that data back into the control plane. So you can see whether your custom script was successfully done, whether it failed, whether it took too long, whether it timed out, whatever those operations can be. So ARM defines, Azure Resource Manager defines this contract that resource providers must abide by. What are the rules of the road? If you're going to be a resource provider, you have to model your resource this way. You have to make sure that your resources can live in a resource group. That's the identity then of your resource. Then you can have other scenarios where you need to allow those resources to be movable from one resource group to another. That is then a contract that Azure Resource Manager sort of defines and then resource providers implement. So things like export requires different schema to be published. Activity logs requires different operations to be documented. ARM defines a lot of these contracts with resource providers and then helps the resource providers make sure that they can be successful define those. So there's lots of other third-party providers clients that can use, that can interact with ARM, open source patterns, different public portals. Terraform, we'll talk about Chef, Ansible, Puppet, and other open source ones. So that's kind of ARM in a nutshell for those brand new to ARM. And then sort of one other example to sort of just think of now specifically about this ARM template and sort of what could happen here, where you could define all of these independently for a particular virtual machine, a set of virtual machines in a VNet behind a load balancer, and then do all of the different relationships that link these different resources. Or you could have a template do all of those things for you by submitting a template to this particular API endpoint where in a particular resource group, you're submitting a deployment, and a deployment can make all of these things true, including, as Brendan talked about, the retrying logic, the wiring it up, all of the dependency management across what needs to be created first, what needs to be created second, and any of the throttling logic required if it gets some retry happens, if a resource provider doesn't happen. Because in this case, these resource providers aren't that well aware of each other. You think of ARM providing a lot of that orchestration across this, that ARM is a multi-tenant service that runs across every region. When you connect to ARM, you don't really care which region it connects to, but it knows how to talk to the compute service, let's say in East US, if that's where the VM is, or if a VM is somewhere else. Or if you have a resource group with VMs and multiple ones, it'll sort of do all the right things to make sure that those VMs are created in the right regions, talking to those right endpoints. So that's all of the things that ARM provides. So now, the sort of really interesting part is we've had ARM for a while, and sort of through lots of customer conversations, we've sort of realized that there's a lot of different patterns that exist out there. So we wanted to spend a little bit of time sort of presenting some of the patterns, presenting some of the factors that go into the patterns, and really to try to help you, regardless of where you are in your journey to the cloud. How can you sort of learn from some of the community, learn from some others that have been in your shoes, sort of living the sort of same challenges you have. So we're going to sort of talk about this sort of these different options of sort of where you're declarative and sort of what the world looks like today, and sort of every release sort of this changes, and sort of this you get more options. So let's talk through these. So imagine you've got these 4 boxes. You've had this sort of scenario above ARM where lots of people in this room, I wouldn't mind knowing how many people feel like they're more of an enterprise serving sort of their enterprise scenarios within their corporation versus they're an independent software vendor. Can I get a show of hands? Who's on more of on the enterprise side in this room, pretty good, and then hands down. And then on the ISV side, are there ISVs in this room? So that's actually an interesting mix of two, which is going to be fun because we're really going to try to talk about both. And obviously, you're part of every equation. So those ISVs, you're trying to hopefully make something that customers can use, and customers, you're hopefully going to benefit from what these ISVs producing. Otherwise, they won't be successful. So on the above ARM case, if you're an enterprise, think you're typically, most of the people we talk to at Build are working with many teams. They're part of some central organization that is defining their roadmap of adopting the cloud, of extending their data center, creating a data center in a cloud, some space that teams can kind of go and explore and hopefully not run with scissors, being held the wrong way, that you can help them be successful. You can keep your executives out of jail, out of problems. And there's lots of different scenarios that our customers are using from ARM, above ARM, different automation tools, different open source tools. And sometimes those are orchestrating things in ARM. A lot of times those are also having to orchestrate things in other systems. You've expanded your network to Azure, and now as you're deploying virtual machining in Azure, you're also having to mess around with an IP address system to assign those IP addresses so that they're part of the same space. So you're sort of orchestrating really across both of those. Maybe you're using Terraform, maybe you're using your other orchestrator. And from the sort of outside Azure piece, maybe it's a DNS scenario, maybe it's an IP address scenario, maybe there's some sort of external monitoring system that you're having to integrate with. So you're having to sort of orchestrate those, and if those don't have resource providers in ARM, they're sort of not addressable by ARM right now, and we'll sort of talk about how that potentially changes with some stuff that we have now. So we talked about ARM having these APIs, and we definitely see lots of scenarios where customers are using both. In some cases, they're using APIs directly and imperatively creating a NIC, creating a disk, creating all of the resources required, and then wiring them up in their own way. In some cases, very successfully for the scenarios that they've supported. And they're not deploying templates for that entire thing. Or sometimes they're deploying templates for the individual pieces, but then they're still orchestrating creation of the end-to-end scenario. Like maybe they have one for a NIC, one for these different public IPs, one for these, but they don't have the Uber template, the template that can orchestrate it all. So they're leveraging sort of ARM for its individual resource composability. We've also released this thing we call policy. We'll talk about policy a little bit. And policy, for its first little while, focused really just on this create flow. As different things were created through templates, policy could be applied on things that were being created. Policy now is really expanded to all of the things you can do. So whether you're creating it imperatively or creating it through a template, or sort of doing some other operation, if you have a policy that says, I can't change this particular resource to not be encrypted, you can block that regardless of if it's a template or a policy. So those are some of the scenarios we see above. In many cases, as we'll talk about the factors of these, there's sort of no right or wrong now. A lot of times you've built these systems depending on your own skills, where you came from, what are the things that you did in the on-prem space, and as you've matured through the cloud, you've sometimes brought those tools along and made them sort of meet your requirements in your teams. Now below ARM, clearly you have to use APIs to touch any Azure services, and as we talked about, these Azure services have this sort of resource provider control plane, data plane sort of break as to sort of what you can do, what you can't do. There are also other cloud native platforms like Kubernetes that have the ability for these open service brokers to sort of reach back in and provision other things. We're seeing lots of teams starting to leverage things like Helm and deploying their applications into Kubernetes, and then having open service broker create different things in different resources that they want, and being multi-cloud from sort of leveraging that cloud native platform. We also at this conference just private previewed an open source Terraform resource provider. Terraform exists as a client above ARM, where it ends up running imperative APIs against ARM and creating resources because you're really declarative within Terraform. And now with this Terraform OSS resource provider, it can reach in to other Azure outside services, and we support 3: Cloudflare, Kubernetes, and also Datadog are the 3 Terraform providers that from ARM you can go and produce different resources and manage them in the lifetime of ARM. So from an ARM template, an ARM policy, things can apply. So that's a sort of kind of summary of the world that we see today, summary of sort of being declarative above ARM, being declarative below ARM, and the sort of requirements that we hear our customers or considerations of sort of how they got here. Sometimes is because they had a multi-cloud requirement. Sometimes they had sort of lots of lift and shift scenarios. They had virtual machines here, and they had to just sort of move them. They couldn't re-architect their app. They couldn't get to containers in sort of step 1. And in some cases, they didn't have the ARM template knowledge, and they're still learning ARM templates. And lots of people have come to the booth talking around, this is where I'm at today, but help us move forward. Where should we go? What do you recommend? And a lot of times it comes back to your requirements, your short-term, long-term. So we'll sort of talk more about the sort of the journey, the challenges, sort of the things that we see across these different levels. Sort of what does it look like above ARM? A lot of times it's around being multi-cloud. A lot of times we see customers don't want to use our portal, want to have their own request portal that they can link in sort of approvals, different sort of force customers to sort of really define the things that they want to do and sort of really hooking that into Azure and letting their systems and the things that they request and the things that their teams do, letting those connect into Azure in a way that makes sense for them across all of their other orchestration. It needs to go to the department has to sign off it, and then only then will they get it. Sort of what do these look like? That's a lot of times where teams have automated these. Really the thing you've got to ask yourself is if you are orchestrating things across different imperative APIs, introspection is going to be a problem, as Brendan talked about. You may complete the virtual machine, you may complete the scenario, but you won't have, it'll be hard to troubleshoot what happens when something goes wrong. How do you also stay on the treadmill of Azure services that are coming off? How do you continually scale to understanding all of the different richness of Azure services of as they improve? Virtual machines didn't have managed disks, and then they had managed disks. They didn't have accelerated networking. Now they do have accelerated networking. How do you stay on that treadmill of keeping up to date to all of these different pieces? And how do you make sure you take advantage of all of the cloud richness of the services that are provided rather than sort of just some common denominator of sort of core services that you're using? Those are some of the things that we hear of customers using things above ARM. But composability comes up a lot from our customers on how do they make sure that they don't have to have the same definition for virtual machines across all of their templates. How do they have a core set that they can be specialized, and how do they use the right nesting template infrastructure to be able to achieve that goal? Some of those things are hard. How do they maintain those? And then in the sort of middle of the ARM journey, if you think of customers leveraging templates that were trying to use templates, a lot of things that we hear is they like the ability to port these across Azure environments, different Azure regions. They also work in Azure Stack. Templates are portable across those. You do have validation of a template, so you understand if the template's going to work based on the resource providers defining whether the templates are expected to work. We're still improving the ways that templates get validated and sort of looking at when a template said it was validated, but it still failed, making sure that those are added to the validation logic. Now, a lot of scenarios that we hear are templates are hard. It's hard to create templates. It's hard to understand how to use them. Now, it seems to be shifting over the last few years. We didn't have the greatest documentation on what the resource providers expose in the APIs. So far, we've heard a little less feedback on that than previous events. but the tooling around templates. Some customers have sort of really come to our booth scratching, saying, where are this tooling for testing a template? How do I sort of understand if there are sort of linting rules that I can run on my template? How do I make sure my template is providing my security best practices and never has any public IP endpoints on it? What do I apply that logic to a template, and when do I let a policy sort of fail it late? Right, we just like as Brendan talked about in sort of the code review process, we want to really take the heart of the what a template should do and the rules on a template and really push it earlier upstream, so that a developer checking in, or if you're checking in that infrastructure as code, how do you fail as early as you can in that process and have the right linting rule apply right there, rather than sort of being blocked by policy validation later. So in many ways, sort of stretching that infrastructure of ARM sort of up and down into the different scenarios, so that you understand if they're going to be successful. We some customers ask about sort of what-if scenarios. Those are things that we want to hear your feedback on what are the what-if scenarios that you want to do. We have a rollback feature that we're working on, where it does allow you, if you fail a template, you can roll back to a last good known deployment, and that's something that we're working on. Sort of below ARM and sort of some of these cloud-native platform scenarios, as you're looking for portability across clouds there. A few customers have asked us, hey, I'm using sort of Draft and Helm. How do those compare to sort of inner loop tools for ARM? And its control plane and data plane is sometimes its definition for control plane data plane is sort of different than ARM's control plane and data plane. So if you're using these are definitely something we'd love to talk to you at the booth run. One customer that we've been working with closely, and we'd love to have sort of other stories as we develop this deck and develop sort of the community around this, was GSsoft. GSsoft, probably like a lot of customers in this room, started using Azure. In this case, they were sort of an early Azure customer 5 to 6 years ago, but they were around before cloud, and they had sort of the classic mix of two teams. Sort of a group of teams that existed before cloud and a group of teams that were sort of born in cloud. And it's sort of I sort of call it the bowling split. I'm not a big bowler, but if you have one bowling ball left and you've got 2 pins, you got to choose. And a lot of times we see customers struggling to choose. Which do they cater for? Because in many cases, if you do it correctly for the sort of pre-cloud teams, and maybe the teams that grew up in mainframes, you're sort of doing it in an incorrect way for the sort of born in cloud teams, and sort of vice versa. And if you sort of focus too much on the old teams, the born in cloud teams break out in rashes and can't even understand some of the challenges you're sort of applying to them. They were using Azure, but not very proactively. They had many teams sort of off going, doing their own things, which meant because when they got started, they started in the Azure Service Management case and had a ton of subscriptions because of some of the RBAC challenges there and co-admins. They started using ARM, but they weren't using deployments. So around 2 years ago, they made a really conscious effort to migrate to ARM, to really standardize on ARM, use ARM, and really depend on templates for their environments, for their deployments of their apps, and really fill in sort of a lot of the scenarios that app teams need. Some of the things that they leverage, they have a whole CI/CD pipeline where they have ARM templates as part of code that are checked in. They have around the last 15% that have done through PowerShell. They have sort of 2 iteration templates. They have templates that deploy some of their base infrastructure, different VNets, different key vaults, and then they have sort of the application layer that uses a lot of these outputs as inputs. And then they sort of orchestrate the two. They have not running environments so that they can deploy their ARM templates quickly and test if their ARM template worked in a way that makes sure that they didn't break backwards compatibility of their templates. They are now starting to work on a lot more governance scenarios, so that sort of they're by design around different tags that they require, different naming conventions that they apply to make sure that all of these different teams sort of have good strategies across all of their different environments, test environments, development environments, production, performance environments. They are working on now completely removing all of their developer access from their production environments, so only their tools have access. Right, so you have now no chance of something happening imperatively and then the next template deploying by accident, scaling everything back down because someone scaled it up and no one knew it and the parameters weren't there and you couldn't see and you caused a live site. And a customer earlier this week told me about that exact same scenario that happened. But also sort of, and maybe just as importantly as sort of giving a technology solution, they've also spent a lot of times with the teams to help them understand sort of why this is important, how it helps, supporting from a central perspective across these different, now 4 products to 15 teams. How do they participate in the code reviews? How do they participate and give teams hackathons to try different things as they were trying Key Vault? As they are now are trying to move to MSI, this managed service identity, so they don't have to worry about keys at all. What is that evolution to continue making it easier for teams to deploy their app, focus on their app, and still meet your different security guidelines and network infrastructure guidelines and other best practices? And share those recipes. How do you include those teams in those? They seem to get a lot of benefits from there, and they've reduced the number of subscriptions almost in half. Are completely working right now. Users are still contributors, but they want to remove them from some of the production pieces and get them to just read only, or actually completely removing them. And yeah, this is sort of a case study that may apply to you. And if it doesn't, this is definitely where we'd love to learn more around where you are in your journey. And what are the mix of problems, mix of challenges, mix of places where you are today, and where do you go forward? What are the right things for you to look at to make the way you're using templates easier across many teams? So we released this ARM Terraform private preview this week. This is the sort of thing on the bottom. The existing Terraform, a few customers were confused on it at the booth. So there's been Terraform support for ARM for a while. It's definitely very much growing in popularity, so that from Terraform you can create your templates, you can make them, you can create your configuration in Terraform, and Terraform has support for lots of different Azure services. And Terraform then, you manage your declarativeness in Terraform, and Terraform allows you to deploy it and do different what-ifs and rollbacks in Terraform. With this template, this resource provider that we have a private preview of, it's really sort of for that bottom side that we talked about on that slide earlier, where now you have a Terraform resource provider. So from an ARM template, you can instantiate a Terraform provider, and you can then manage its life cycle. You can do different operations on it. And because it's now a resource because it's a resource that is addressable by ARM, almost you can think of it sort of like a class provider, where through this resource provider, Microsoft.Terraform OSS, you can actually see, you can instantiate a particular type of a type of provider like Cloudflare or like Kubernetes or like Datadog, and then from there you can actually do different operations, potentially across things that from the Azure resource provider we call data plane, so not control plane. So let's take a look at some of these templates and do some demos. So in this template here, I will zoom in. This is a template that uses an existing Kubernetes deployment in Azure. And here it's accessing this new Microsoft.Terraform resource provider, and it's doing a provider registration. So it's registering this provider type Kubernetes, that's the Terraform resource provider, and giving it an inline config that it requires, a different version on the Terraform side. And then it is creating a resource, and it's doing a container deployment into that Kubernetes cluster, something that you can do with this Terraform provider. So from the portal, Just reconnect my Cloud Shell. From the portal side, I'll show that here I've got an AKS cluster, and I'll just bring in just going to connect my Cloud Shell to this subscription. And I'll show that there are no, there's nothing running. There are no pods in this, and I'll just, whoops, get my credentials local. And if I do a kube control get pod, you'll see that there's no resources found. So what I'm going to do is I'm going to deploy that template, and all of these templates are in a GitHub that I'll share a link to at the end. And I'm going to use the existing deployment and create terms, dashboard, and I'll send the deployment. So now the template that we're showing over here, you can see the template here just requires an AKS cluster to be passed in, the location of the resource provider, and then we'll create this pod. So the template's being submitted. And once that finishes, we'll look to see if the pod is created from this template deployment. Anything else to tell you on this? We'll show you a few of the other Cloudflare deployments in a second. So this template is now being submitted to ARM. ARM is invoking just like it always does across all of the different resource providers. Now it's finished, and now we can see if we do a kube control get pods, we can see that now that Nginx image is running in this particular container. So we were able to do this data plane operation through this Terraform resource provider. And now, in this particular resource group, you can see both this AKS cluster registration defined as a resource, and also this Nginx demo, which is this image as a resource. Because this image is now a resource, we can apply other things to it. We can apply locks to it. We can do different RBAC controls against it, and we can also apply policy to it. And this is something, if you were using Terraform sort of above ARM, you weren't able to do because it wasn't sort of an ARM-tracked resource. And ARM-tracked resources sort of have all of these different capabilities. So if I grab the same template, for example, and we have a policy defined here that will help us understand. Let's say we had a goal that no particular version of an image is deployed that's less than the particular version we've specified. So I will go and just change this to a version that probably doesn't exist, but I'll just make it a little bit less. So I changed it to 1.6.8. I'll use the existing resource group. And now if I try to deploy this particular template, and I'll show the policy in a second, we get this validation error. Oh, sorry. We get this validation error here that says, wait a second, you tried to do a template deployment, and this template deployment didn't work because there were validation errors. And this validation error, if I click on this here, we'll see a little description of the validation error here. We're working on this experience to be able to drill in right into the policy so that you can see it. But here it does say that this is disallowed by policy. It gives it the policy ID and said that it is requested disallowed by that policy. Now let's go and actually take a look at that policy. And this is still in a public preview that's about to GA, where Here we have this policy center, and we have this Terraform Kubernetes demo policy. And if I look at this definition of this policy, we can see that in this JSON definition, it's basically just requiring the version of this particular resource, this image resource, this now sort of addressable resource that wasn't addressable before because the resource provider didn't expose it, can now be applied. And now you can centralize that ARM policy across resources that you deploy that are resource providers today or come through resources that are discovered and addressable now through this Terraform resource provider. So that sort of showed the ability of using this Terraform provider to instantiate this image in this Kubernetes cluster, and then also denying another one through policy. There are lots of other samples that we have. We have the Datadog sample, we have a Cloudflare sample, and we have this Kubernetes sample available on this GitHub. In this example, this is a really, really big template for Cloudflare that I'll basically summarize saying it creates a WordPress on an Azure App Service and instantiates it all. In a resource group, it gives you an app service, it does all the right WordPress configuration, and then it leverages, and I'll drill into that at the bottom here, it leverages the Terraform Cloudflare private preview support we have. Just like the Kubernetes one, there's a way to instantiate this Cloudflare type. And in this Cloudflare type, you have to provide an email and a token. This is for your Cloudflare subscription. And then it allows you to set up configure all of the different website information. So passing in this case, a particular Azure website URL, some name I use, vladjbuild.azurewebsites.net, passing that to the Terraform Cloudflare provider, and then registering it in Terraform and getting an official DNS provider supported there. So I'm not going to execute this now, but I'll show you in this resource group where I ran the exact same, where I ran the template last night, and you can run it once you sign up for the private preview and get this provider registered for you. Now I have this Azure website, this vladjbuild. I get all the different resources similar to the Kubernetes one. I've got this Cloudflare resource and this DNS CNAME resource. This both registration and resource there. You can see that specified. And then I've got it registered under this vladjbuild Simon G. Davies URL, and this is the sort of Azure website URL. So you can play around with those. And we'd love to hear your feedback. Later this afternoon, I've got the session reference after Arun from Microsoft and the Terraform team are giving a whole session on the Terraform provider, both from sort of above and below, and they'll also get into more detail, and I'll attend that session as well. So switching back to slides, a few other template improvements that are coming that we wanted to show. We have these things called user-defined functions now available in a template. So there's now a function section with a template, and I'll show it where you can define a set of reusable functions that you can use. So rather than having to sort of inline them every time you wanted to use them, you can define them sort of once in a template and reuse them. We also have an ability, and I'll demo this, to create a subscription-based deployment. So today there's certain resources that don't exist at the resource group scope that really exist at a subscriptions group scope, like a policy definition, a policy assignment, or other things like a role assignment also exist for a subscription at a subscription level scope. Those weren't possible to address with a resource group template, so we have a subscription-based deployment. This is still rolling out, and the client-side tools are rolling out. And I mentioned rollback a little while earlier. So, switching back to demo here, I'll show this. This is our sample, also posted on the same GitHub, where you see there is this now function section. You can specify within a namespace a number of different user-defined functions. So storage URI now is addressable function within that template scope. and it could pass in a set of parameters and pass in a particular output that gives you sort of a storage account name specific to the cloud that you're using in. So maybe you have different functions for giving your storage URI in maybe the public Azure instance or one of our national clouds. That it would sort of change what the string is. Or maybe you have one for processing sort of different dates and standardizing that, or you need something to sort of look for sort of odd outputs, evens, or do a get subscription ID. Once you specify these, once you create these, then they're addressable either in parameters, variables, resources, or outputs. They're leverageable across all of those different ones. So that's something you can play around with. And then on the subscription-based deployment, this is where you can now create things like policy definitions that exist at the subscription-based scope through a template. You can do policy assignments, or you can do different role assignments. And I'll demo role assignments in just a second here. And in my case, I'm going to make Brendan a storage account contributor in a subscription that he doesn't have access to. And like I said, these different tools are still rolling out, so I have to do it from a virtual machine here. So here you can see that Brendan doesn't have access to this particular subscription, My Visual Studio Enterprise, and I'm going to run this particular template. This is going to do a subscription-based deployment. You can see here it's a new Azure RM deployment. And it's going to create a policy definition. It's the same one that we have in the GitHub. A policy definition, a policy assignment, and then also a role definition. And these client-side tools are still rolling out. One of the scenarios that isn't available right now, but will be likely towards the end of May, is also being able to create a resource group. So today, you can't create a resource group with the template. You have to create that in other ways because it exists at a subscription level. This will also allow you to create your different resource groups. So now, if I do get Azure role assignment, we'll see Brendan is accessed here. Now he is now a storage account contributor, and if I go and refresh this portal over here, we'll also see him as a storage account contributor, right there for people in the back. Oh no, I actually can't zoom in because this is on a term surf session, but I can zoom in like this. There. And now you've got to know the principal IDs of your users. So if you have scenarios where you have a whole process of establishing a resource group for a team, right now, if you have subscriptions that are shared across teams, now you can use some of these templates to give users access to those to create the resource group, and then give users access to those resource groups so they can do the things that they need to in those resource groups. And you can use templates to kind of continue your journey of keeping the identities in sync as it makes sense. We spend a lot of time at Microsoft. Obviously, our different services have certifications that are different three-letter acronym soup things that I never remember. But there's a lot of things that specify exactly knowing who has access to what, and regular reviewing it, doing quarterly reviews on it. And we spend a lot of time trying to make sure that it is as automated as we can based on our organizational structure, right? Lots of people change teams at Microsoft, leave Microsoft, come back. How do we understand that the right people have access? How do we make sure that the managers are regularly approving that? How do we get all of the right documents required for the auditors so that they feel like they have sort of plausible deniability of we've done everything we can to make sure the right users have access to the right things, and they don't have access to the things that they shouldn't have access to. So we think some of these subscription level deployments will be interesting for you to use and try. So those are some of the improvements that are coming. We showed that demo. One of the things that we're working on designing that we want to talk about briefly is the ability to have modules. Today, think of these as sort of server-side stored templates that you can save and you can leverage and you could use within your templates. You can leverage them just like you do today through a different nested template that you bring in, but you can use these as sort of first-class resources that are defined and stored and leveraged and used in the system. This isn't available today even as a private preview, but it's something that we're working on, testing with customers, understanding sort of when it solves problems, when it doesn't, and something that you can leverage from different templates today. So that's on the consumption side. Sort of on the production side of Azure, the way that you expose your services to Azure, we sort of have this graduation process from quick starts. Hopefully everyone in the room understands what quick starts are. We'll talk about quick starts. This is a community-based, curated gallery. Brian here in the front row spends time reviewing every pull request that comes through that quick starts as he sort of curates it for best practices, for sort of just working across all of these scenarios. He has a set of rules that he runs across those to make sure that they're great, and rules that we want to make sure that you can apply to your templates. That sort of has no monetization around them. Think of them really as just as a community set of templates that are great for samples, great for getting started with ARM templates, and then sort of customizing to your own needs. As you think about the sort of next step, and it really builds on this, and you'll see the theme here, a lot of this builds on this template definition, this configurative deployment of how do you take your app, if you're an ISV or if you're an enterprise, how do you take that app definition and really make it repeatable? Really think about what are the external inputs that should be fed into this configuration to make that app great. Maybe you have a field that allows the user to deploy a highly available version of your app or a test version of your app, where obviously things don't have to be redundant in your test version, but are in your highly available one. That's what a solution template you can have that as a quick start, but now as taking it as a solution template, you're taking that template and publishing it in the marketplace so that everybody in the world could see it. You're jamming it with a configurable UI experience, so now you can also have a pleasant experience to help a user stay on your rails and choose all of the different options required for your template to be successfully deployed. And this could be then deployed across any Azure region. A customer chooses it, and then they're responsible for executing it and running it. We have the service catalog capability, which is similar to this managed app, and I actually have slides on each of these, so I won't spend as much time on these ones and sort of a flow for where managed app makes sense. And then we have sort of the two at the bottom. The bottom one is fully available today. It's something that all of our internal teams have produced, some external teams have produced. And this is a full-blown resource provider. And we're trying to sort of introduce something in between that we're calling sort of resource provider as a service, where it makes it much easier for your resource provider to build a resource provider, to expose a resource provider and have a first-class resource provider experience like we showed with some of the Terraform scenarios. So the quick start, the link is here. There's lots of integration with the azure.microsoft.com experience, the Azure portal experience. There's no direct sort of monetization from there. Brian, we should probably create like a prize or some sort of top 10 or top deployment, top used. And if it's a community one, we should definitely maybe do some prizes if as long as we don't get in trouble for doing that. On the solution template, as we talked about, it takes your template and gives it a way to be exposed in the marketplace for anyone to consume, anyone to use, and really give a turnkey approach for running it. But then the customer is responsible for maintaining it. The customer will have to upgrade it. The customer will have to figure out what to do to update it, to change it. All of those sort of things are things that a customer would do. And we didn't think that was sort of quite sufficient. So we've been working on and we GA'd last year, and we're working with a lot of interested parties and customers on this new pattern that we've had for managed apps. So if you think about it, for a lot of years, the software industry was really an ISV built some software, and gave it to a customer on a CD or a floppy, and the customer installed it, and then basically called 1-800-ISV whenever they had a problem. And the world worked for quite a while, sort of on that premise. Now, then customers started taking those software that we gave them and actually started running them in their cloud accounts. And then sometimes they actually gave that cloud account sort of access to the ISV. And now the ISV had access to the customer's environment in a way that they never had access to sort of in their on-prem environment. And that made ISVs realize, wait a second, if I can get access to the customer's environment, why don't I just run the software in my cloud account? And then I'll give the customer access to the software and not access to this control plane. Because here they had access to the control plane and all sorts of bad things happened. They stopped it, they broke NSG rules, it didn't work, and then I had to change it. So let me solve it by deploying it mine and giving them theirs. Well, then what happened is a lot of ISVs realized, wait a second, maybe I should build a multi-tenant version of my software and have one stamp that many customers can use. But I got some of these really big customers that I'll actually have a custom stamp for. And that sort of worked for a while. And then customers said, wait a second, I have a way better purchasing plan than you have for cloud, and I've already paid for it maybe. I want it actually in my subscription. And at the end of the day, the ISV had all of these things to worry about. They had some customers running it, some customers where they were in their cloud subscriptions, some multi-tenant instances, and they basically had 8 problems now rather than just sort of one. And in a lot of cases, it was the same code. But the code for the app and then the requirement to manage the app and to scale it and do all of these other things was getting really hard. So what we've been working on is sort of the ability that an ISV can define this thing we're calling a managed app, which is a template. Could be the same solution template that you have that we talked about before, same GitHub template, that a customer can deploy or delete. But then what a customer gets is it gets deployed into their subscription, into their resource group. But in addition to that, you have another resource group that we call the system resource group, where you have all your ingredients. And that managed application in your in the first RG that we showed is basically the strongly typed resource for whatever your ISV app is. It could be MarkLogic, it could be DataStax, it could be Cloudera, whatever SharePoint, whatever your managed app is. That's the thing that they can delete. And there's one or as many times as they created your managed app, you would see that many instances in that managed app RG. But then the ingredients are all of the things required to power that particular piece, right? It's all of the things under the hoods of our cars that we don't sort of really have to pay attention to that much anymore. But in this case, the partner, ISV, is a full owner of that system management group, that system resource group, not management group. All of those ingredients are fully owned by them. They have access to the control plane. The customer actually doesn't. The customer just has access to see it, to read their read only, because they're paying for it. They can see the line items for each of those costs. So this is kind of the pattern we've enabled, and it's fun to see sort of as many customers as ISVs in the room, because this is a pattern that requires both sides of this equation for it to be successful. Right? It has to be successful for the ISV, otherwise they'll go out of business, and it has to be successful for a customer, otherwise you won't be able to use that ISV. And this is where we're working on improving what it can do today, and how it can be how there can be monetization. And sometimes ISVs don't want all of the customers to see the ingredients. They feel like some of those ingredients are their IP. Sometimes it's things that they don't have. A lot of times it's things. Sometimes it's things that they don't even know how to maintain those things. Customers are better maintaining it. Sometimes it's not the ISV that knows how to manage that app. It's the ISV's partners. Right? They have a Europe partner. They have an Asia partner. They have partners that know how to manage them, and they couldn't manage their app if their life depended on it in some cases. So these are the things that we're spending a lot of time exploring, but it needs to work from both sides, right? It has to work for a customer, right? You're the one that is deploying their software for your scenarios to work, so you have to be able to feed it data, work at the data plane level. and still at some point make sure it's compliant because it's deployed in your subscription. It will be sort of visible to you. It'll be under your compliance view, but yet you don't have access to it. So if the ISV doesn't patch it, and you can't even scan it to understand if it's patched because you're sort of just a read-only user, that's clearly a problem that we've got work to do to sort of solve. But we're really looking at making this a first-class experience. Today, a customer can create it and can delete it. And clearly, there needs to be another life cycle of scenarios that an ISV exposes for those apps. You should be able to shut it down. You should be able to scale it up. You should be able to scale it down. You should be able to given some high-level knobs, just like on the car, we have different knobs, without having to sort of go pull the different line for the throttle under the system. Those knobs should be powered by the ISV. The ISV should know how to do those. You should those ISVs should know what you're doing, when you're doing it, and that should be audible. In some cases, you should have JIT enabled. So if an ISV wants access to your environment, maybe it shouldn't be long-standing. You should be able to sort of just-in-time your way into letting the ISV access it. So neither of you have access to it for long-standing purposes, just like you would never have your own users accessing production resources for long periods of time. So that's what managed apps is all about, and hopefully you can give us feedback on sort of if it works, whether you're a customer or you're an ISV. Service Catalog is essentially the exact same scenario, but within a tenant. So rather than an ISV and a customer, think of it as sort of a central org within a company, maybe a central department, head central, that offers it to their customers. And it could be now very specific to the customer environment. So you could say, I'm going to offer SharePoint in the domains that make sense. So the Microsoft IT team could offer a SharePoint template that's customized with a drop-down for the different domains that make sense for me as a Microsoft user. And I can choose it in this domain or that domain or whatever the scenario is, plus wiring it up all to the monitoring logic that IT team uses. This is what Service Catalog enables, sort of the same sort of two-phased sort of market on customers. So service as a service, or sort of RP as a service, making it easier to implement ARM resource providers is something that we're working on actively right now. Internal teams will definitely, internal to Microsoft teams, will likely see an evolution of RPs where you shouldn't, as customers directly on top of the stack, see the difference between these. That should just be complete implementation detail, but we're really making it easier to build and maintain, and hopefully this makes it easier for ISVs to build and maintain. And some of these concepts will also be leveraged in that ways to extend managed apps with different strongly typed methods and different resources. So this is something that if you're interested in, definitely let us know. And then finally, there's the resource provider, which today is definitely the most popular, and it's the most flexible, and it's the highest cost, both initial and ongoing. And it works great for multi-tenant, and billing is your oyster here. You can bill sort of the billing meters that it submits, that it produces, can be very, very flexible. And the marketplace team is also working on ways that they can make billing easier for their scenarios. And we have that resource provider contract spec available in a public GitHub so that you can read it, and you can see if this makes sense for you. We can talk about it, but we'll definitely try to get you into the sort of RP as a service pattern rather than our own. So in terms of managed apps, we've got about two minutes left. I'll just show this slide. Today, if you run a managed app, you will essentially see the output of a managed app is for a customer. This is from a customer view, is very rudimentary. You'll basically see the inputs and outputs of the template that was submitted, and then that will be used to get to the data plane URL. We're working on improving it so that a managed application can actually customize the user experience that a customer sees. So if that managed application includes a workspace and includes a view definition that leverages some queries in that workspace, in this case, OpLogic up here in the front has a way to specify a tile for the number of Oracle machines monitored, and allows that to drill into a very customized dashboard that they've built as part of their managed app, part of their service that a customer can get to and can view. We'll definitely continue to make this great, but it needs to be great by, again, both from a provider side, the ISV side, and the customer side. It's sort of both sort of one of these complicated sort of two-phased markets. So we talked lots about the different ways to sort of publish your things if you're an ISV. Brian and Patrick had a session on Monday that talked to lots around the different ways that you can publish things into Azure Marketplace, into AppSource, whether you're, and then the way you use them from the IT side. There's lots of usage, and there's definitely the sort of single place that we even publish all of our own things in Microsoft are published in the same marketplace, not just third party. So really the summary to call to action is keep this conversation going. We would love to hear sort of where you're at in the evolution. What are the things that you feel like you've done that have solved things for you, and where can we still keep improving? Like Brendan mentioned, we'll be at the booth for the rest of the day, but we love to set up one-on-one design time review sort of in Redmond. We do have, if you're not flying back tomorrow right away or tonight, we do have some time in Redmond that's open from sort of 10 to 2. You can stop by and see me or Brian, or stop by the booth and we can give you more details. But really understand, try out these new technologies, try out these new ideas, really push to see where you can evolve your own infrastructure as code scenarios, where can you push more of that into your inner loop, what are the ways that you can make things more repeatable, more introspective, just like Brendan talked about, and really refine your vision for what infrastructure as code is. I think it'll be an incredible next few years as we really give you sort of even more tools to manage your Azure usage and make your Azure usage great regardless of whether you're above ARM, below ARM, beside ARM. It really doesn't matter. We want to give you the right tools, the right ways to leverage the platform successfully across all of the services that we have in Azure. Hundreds of different services that are all changing, right? We need to keep you up to date to that treadmill so that you're constantly seeing what was maybe false last month is maybe true now, and how do you constantly continue reevaluating that, just like other teams are doing. They're evaluating new technologies, new hosting platforms. So we're around, available for questions. We've got sort of a minute and a half on this time. Here's some of our contact detail. The slides should be posted pretty soon. If you wanted to take a picture, I saw some people taking pictures. I've just got one more slide on. I've got one more slide on just some of the related sessions. Joseph gave a session on Azure policy earlier in the week. Adobe, unfortunately, it was exactly the same time as now, but I was talking to Adobe yesterday at the booth, and they actually have a whole session where they'll talk about some of their proven approaches, and I'll take their punchline away, is they actually use Python to generate their ARM templates. So some really neat scenarios that Adobe has sort of done through sort of their usage of Azure and their maturation and journey. And then later this afternoon is this whole Terraform OSS session with Arun. And then lots of different references that we had. And there's the template samples. It's just aka.ms arm build. And then the Terraform sign-up link as well is just Terraform OSS RP. That'll get you to a survey. And all of the above links are linkable in the slides once you get them. So definitely complete your evaluation, and if you, I don't know if there are people lining up for the next session, but we can probably answer some questions up front here, or come to the mics really quickly, and then come by the booth if you didn't get your question answered. Thank you very much, and hopefully you can win the prize.